We're gonna get started with our next talk by Sam Phillips, who is a regular in the Racket community. You'll find him on Discord and Discourse and all the places, and he's always helping people and working on cool things. And one of those cool things is Keyring, which is a way to uniformly access secrets in your Racket program so that you don't have passwords in your source code. So
just give away the whole thing. I'm a little intimidated at everyone
take it away,
else's talk.
Sam.
It feels like I'm just talking about here's how you use addition or printf. So mine is, Keyring is mostly a practical thing that I built for my own necessity. It's something that I very much stole from a Python library. So we can yell about Python some more or complain about it. I'm a systems administrator. I am not technically an engineer. And I'm barely a systems administrator anymore, but that's kind of what I do. I make lots of tools. I've been a Scheme Racket user for a long time in my life, but probably not in its history. I'm not a security expert. We'll probably talk about some security stuff, but I'm not an expert. I'm a risk aficionado or appreciator, yeah. We like to look at what is risky behavior, not risky behavior, and let's not do risky behavior, right? So let's just set that up. Right, so ways I use Racket. I log into a network service, I process some data, and I generate a report. Or, oh, come on, yeah. I log into a network service, I process some more data, and I send it to some other service, right? These are all scripts. I'm logging into a network service, and I'll script its API because it doesn't do, it's some proprietary commercial product, and it doesn't do the right thing out of the box. You need it to move a bunch of stuff around, or you need it to juggle users and groups and a million other things that you want to do to make it so you can do a maintenance in some operational capacity. And you want to spend all night like typing in a billion commands. So, automation. And I say services, and this is a small selection of services that I use in my actual job. So like some generic HTTP garbage. Splunk, it's an enterprise logging tool, Nagios monitoring stuff, Amazon stuff, LDAP, Cribble, more logging garbage. And one that's not for work, Spotify, you want to make automated playlists or something, that sort of thing. So you can, we'll look at some just bad or okay things, and here's a really bad example. Let's make a Spotify playlist, and you just pass your password in as the second argument. That's what you don't want to do. And you don't want to put that in Git, because once you push it to GitHub once, it's there kind of forever, maybe. If you force push something that erases it, maybe they erase it. Who knows? This is documented Amazon breaches because people push secrets into GitHub all over the place. It's bad scene. And you have its relative oh, well, I just put it in a variable, right? So the progression here, what's a better example? We'll put it in an environment variable, which there's, now I can't remember what the name of it is, but there's one architecture, and it's closely related to doing things with Dockers and containers, is just put everything in environment variables. Because if everything's in an environment variable, you can have your computational thing in the container, and all its configuration comes from outside. You just inject it in, right? That all works. We're pretending that our server environment's secure, so no one's getting all your environment variables, right? But that's a common thing to do. Or you can just put it somewhere safe on the file system. And then just read it out, right? Provided you have access. Or there's a Git pass package that I don't remember who the author is, but it is on the package server. It actually will prompt you for a password, and you type it in, and then, that's a lot. All of these are preferable options, but of course. There has to be a better way. So yeah, the better way is, I think, you should use the Keyring library. And what the Keyring library does is it just abstracts over all the different access mechanisms. And so, yeah, the three-step process is you load the library, you configure a keyring, which in this case it uses some parameters and a thing to make the keyring, and we'll talk about all those. And then you just use it, and you use it by just calling get password with the name of the service you want to get your password for and your username, and it poops out some bytes. And you pass those along. All right. So there's lots of ways of configuring what keyrings to use. Here's one that you can so you can configure it via environment variables. So this one here, we just have this little tiny program that's just going to spit out what the password is. In this is a little terminal example here. We're going to set the keyring environment variable to keychain. It uses URL syntax, and then you run it, and the keychain is inside Mac OS, whatever. Keychain is a built-in OS facility for storing secrets. So you can just set put all your passwords in it. It's just kind of like built-in password manager. And then you run the command and it gets it. Or in this case, we can also make our keyring read out of the environment, and we'll say environment, and it's going all the keyring entries are going to start with KR. So then we set, here's what for the test service with my name, what the password should be, and then when you run the command again, it's going to give you the password from the environment, etc. So how does it work, right? The front-end API is setting a default keyring, and then making the keyring from a string. When you load the library, it actually reads, let me go back. When you load the library, it will look for this keyring environment variable, and if it is set, it uses it. If it's not set, it sets the keyring to a null keyring that errors no matter what you ask it for. So we say default, or we make a keyring from a string, and the URL syntax looks like this. It's the name of the backend, then some host settings, which are all configurable by backends, path settings, and then maybe more settings. Right, so getting the password, straightforward stuff. You get password, gives you the password. All right. So there's a couple other APIs that I don't use as much, but are useful to have. One is to set the password and remove passwords. They're also just very straightforward. Sets the service, or you set the service and username, and then set the password, etc. All right. I'm going too fast. I gotta slow down. All right. So here's the secret stores that's default supported. One is the macOS keychain, as I showed. The free desktop secret service, which is pretty much known as Gome Keyring. It also does SSH agent support on X Windows systems. So most people are already, if you're running Linux, you probably have that or something else. Environment variables, which are good in server or Docker environments. And then the get pass package is just you want to interactively prompt people for passwords, things like that. Because you can set the keyring options, outside of your program. Like if I'm developing on my laptop for work, I might use keychain, but if I'm working later in a Docker, I'll use environment variables, so I switch between those. Right. So then the backend. The backend's fun because I pretty much made it so I don't dictate what kind of thing you use for a keyring. So you can use a struct, or you can use a struct with a generic interface, or you can use class interface. And pretty much you just have to implement a get password, a set password, and a remove password for all those, and then it all works. Oh, and then there's the secret magic sauce that isn't defined, which is you need to have each, I think that's the next, yes, there we go. So for how it defines the backends, it uses dynamic require. So you just need to have inside of the keyring backend collection, the name hash is the name of this backend, for example, and then you need to have something called make keyring, and you can pass in those other URL options to that. So if you have other settings, this one is plain. So you would just call it hash :/ as your keyring, and then you could store things in a hash table. This is like a very trivial keyring that doesn't, doesn't persist anything, only runs in memory, and don't run it in a multi-threaded thing because you probably will mess something up. And I'm talking way too fast because I'm almost done now. So someone has to ask some questions, but I have one more slide. So Windows backend, I don't use Windows a lot. There are some Windows secret stores that are built into the OS. Yeah, my Windows computers keep crashing on me, and I'm too lazy to put them back together and don't play enough video games that I need it. So I haven't worked on the Windows one. Pass is a command line Unix application that essentially stores a bunch of passwords in a GPG encrypted file. It is, somewhat standardized. Another thing I'm actually really going to probably start working on is a configuration type backend, which would probably show up as a lang, where you could have layered types of configuration. So you might have the configuration that you read out of some specific store or an environment variable, but some other secrets you might read out of a different store. So it's just kind of a, look it up in the right place type thing. Yeah, that's it. Excellent. You're not on.
Thanks, Sam.
No problem, Sam.
So, obviously, passwords are not the only kinds of secrets that programs might care about. So have you thought about how you would integrate support for like API keys or other sort of kinds of secrets that might be important in a program?
So yes, what I have done is, and I have done this in practice, is you essentially make the username just be kind of a key into the service. So you might have, and in the AWS example, AWS, when you're doing their key-based stuff, authentication, there's a secret, or there's a access key, and then there's the secret key. The access key technically isn't secret, but it's easier to, because they go as a pair, it's easier to store them like that. So the username, on some of them I would just have the service is whatever the service is, and then for the access key, the username I would have access key, or AWS access key, or AWS secret key, something like that. So that's how I've done that one. I mean, generally it's a mapping to some kind of blob of data that, so it just works out like that. So most secrets you can just store in that way. Yeah.
Well, I thank you again for the talk and for the beautiful simplicity of the interface. I just had a question more about the free desktop backend in particular, the Gome Keyring, because yes. Gome Keyring is kind of an arch nemesis of mine. And I was curious about, do you plan to support configurations that don't always deal with secrets, but rather how the secret software actually works? Because I'm thinking of a case where you have i3, a window manager, but it invokes Gome Keyring and it brings up this modal dialog that completely locks you out of some things. So do you have a way for, say, your library to automatically answer GNOME Keychain when it tries to authenticate the user or something of that
No.
nature?
And that is I could say, as a risk aficionado, I can say that is, there's a reason for why they need you to acknowledge that as a human being.
The interactions?
Is because of the interactions
yeah.
and because you're acknowledging like, hey, Racket's trying to access your passwords, right?
Sure.
And it does this on the Mac. Does this too? Every time a new version of Racket comes out, it goes, hey, Racket's trying to access your package or your passwords again. Is that okay? And it's like, yeah, go ahead.
Thank you.
Thank you for a great talk, and this looks like a great project. So one of the things I want to do soonish is for my next laptop, I want it to not be Mac and to instead be Linux. One of the big challenges there is dumping my Mac keychain so that I can migrate it over to the new system. Is your package something that I could use to do that? For example, is there a way for me to ask the keychain, tell me all of the entries that you have?
No, and there's a good reason for that, because a bad Racket library could be it could be some transitive dependency or something, and it could just then go and require keyring, access, see if keychain's available, and then load up all of your passwords and then exfiltrate them to some person, right? So no, it cannot. If you look at the code, especially the Mac code, it's FFI stuff, you could probably, and go and look on Apple's documentation, you could probably figure out how to do it, but I wouldn't add that to this library. Yeah.
Please?
I can give you pointers, but yeah, and another reason is that it wouldn't be uniform across, or it's hard to get it uniform across all the different platforms in that way too. I mean, environment variables, sure, you can enumerate all of them too that way, but it's messy.
Thank you.
No problem. Sorry.
Just a reminder, I know we haven't been reminding people, but say your name when you ask the question. That was David and Sam.
Yeah, David, one quick thing though is, I would say that you can't get your passwords out of a Mac this way, but if you wanted to put your passwords into another thing, sure, that works fine. Because you can set passwords all day long. You just can't list them out. Yeah. Go ahead.
My name is Jorge, or Jagard, our C name. But have you run your library through the mutation testing?
No.
Or what is a corollary to that question is what testing have you done, and what does that look like for this, or what were you thinking about?
Yeah, and make sure that it sets and gets things properly. So it's more like round trip type stuff, especially when messing with the with some system library stuff. So making sure like it can, if it sets something, it can get it. Making sure if I set something, out of band with some other tool, that it comes out the way that it's supposed to. Yeah. So that's one of the choices I made in the interface was for passwords are not strings, passwords are bytes, because I think there's a bit of literal like fidelity, is what I like to say, that you don't want to lose. And if you use like Unicode or something like that for your password, you're typing in with an extended character set, just convert it to bytes, because some of these backends might not even be, I don't know if I can guarantee like how safe they are for encoding certain things. So if you just handle the encoding yourself, then at least it's going to come out right? So.
Do you have time for one more? Yeah. What are there some other backends that you've been thinking of targeting? I know you added pass.
There was one in my brain. I just lost it. Yeah, I can't think of any really quick off the top of my head, but there's lots of space. Something like a files, right? Just reading out of files. Docker has Docker has what's called Docker secrets, which essentially writes your secrets into like a RAMFS in the container into a file, and you just if it needs a secret, it would just read that file. So just being able to access, that's pretty straightforward. It's not too far off from the example one. You wouldn't be able to set or remove passwords in that case, but I mean, 90% of my usage is just getting the passwords out. The only times I really set and remove or if I broke my keyring in some way. So.
All right, thanks.
Thanks.
Yeah, still good. Hey, I'm John Clements. This looks like fun. I use systems like this all the time, and sometimes it's for passwords, but often it's not. Often it's for like configuration type things, like, oh, when I'm on this machine, I should use this port to get to this other thing, right? It's not really a secret at all. It's just kind of a configuration thing, and so I guess then I started thinking of sillier things. What if could my what if I wanted to store like the compiled code, like facile code, or like giant things? Does your library? I mean, in some sense, you want to support the intersection. So maybe this is a very specific question. One, have you done silly stuff like this? But two, does your library say, well, we promise there's going to be at least 256 bytes is going to be supported, or like 1K bytes is going to be supported, or like right? What if I want some guarantee? I move something from one keychain to the other one. It's like, oh, this keychain doesn't support 7 kilobyte.
I haven't tested
secrets.
that.
Okay.
So yeah,
that'd be cool. Thank you.
Yeah, that's definitely like environment variables will probably have some system limits or
right
versus exactly. So I mean, I already have a problem with like environment variables. They don't like hyphens, and a lot of the service names I use are hyphenated. So like for the example, I had to put underscores in it to make it work right.
Have an encoder there? Okay.
Yeah, so one of the things would be to encode, or when you're using the environment backend and the secret has, or not the secret, but the service name or the username has a special character. There's some kind of encoding, right? Which, yeah, that's why it's.
Hi, I'm James Platt. Could you give some more details on how you securely delete passwords from RAM after they're no longer in use, or anything like that?
I can give lots of details on that. I do not. I've thought about something secure RAM, and the problem is that once it passes through the garbage collector, it's kind of tricky. And I think I may have talked to Matthew about it a long time ago, but it's. It's not something that's easy to do. So we pretty much just, you rely on it to be garbage collected. There's a lot of reliance on this that your program is secure when it's running to a certain extent, which is hard to, depend on. But this is modeled after a Python library, and I know that it doesn't do anything special, and I don't think there's anything more secure about Python than Racket.
What I've generally heard is that you want to use whatever operating system you're on, you want to use a built-in function from that operating system to delete passwords. So
yeah, and maybe I'll talk to Matthew about this, because this is like this is really kind of an internals question that I'm not totally sure about, but it has to, because WoodUB is like scrubbing a part of the heap, I would think.
Exactly.
And that would be
it's iffy.
Weird. I mean, you could just, you could just write random bytes over it somehow,
this is one of
maybe.
These hard
but you'd have to know that.
Yeah.
You'd have to have a handle on that byte string, right?
Yeah. This is one of these really hard problems in security.
Yeah.
So that's why I ask.
Yeah.
Okay, thank you.
No problem. Yeah, not a security expert.
Just a request. The little sysadmin. Thank you.
Yeah.
I'm not kidding. When I came to Northeastern, my sysadmins were writing and publishing books on how to do sysadmin in scripting languages. And you've just shown, with your question and answer period, there's a real need for a good book in Racket.
All right, let's hear it for Sam.